If your code looks like this, we need to have a talk. Yep, this is the way most beginners write their code. And it works for now, but as you expand and grow your app, this becomes a nightmare to maintain. So I'm going to show you today a technique that Apple uses throughout their code. It's called the delegate technique. And this pattern can be applied to solve these types of situations. I'm also going to show you where not to use the pattern. This is episode 4 in my series on protocols. So if you missed some of my other ones or looking into more of the fundamentals, check out the link there and check out those videos. All right, let's look at the issue with this code. Let's pretend that I'm Professor Xavier and I've got to create my X-Man team. To do so, I need my battle simulator so I can figure out how we're going to do in battle. And you also want to look at the stats for my team. So then when I save my X-Men roster, I create a team. Then I assign the team to my battle simulator. I assign it to my stats panel, and then we can run the simulation. Now let's see how we do. And when we run, we get this nice little printout saying how the simulation went and what our stats are. Pretty cool. While this is neat, what if I want to add a lineup? So I want to have this lineup card and I want to incorporate that into my printout. So, first I'd add my lineup card and I need to assign the team to it. Next, I want to print out my card and then we want to roll this whole thing again. And great. Now I've got this cool lineup card and it all works. And then what if I want to add something else? What if I want to add like a training scheduler or a mission briefing or anything else? Well, this gets pretty out of hand. I'm going to have to add a new thing for every single one of those, hook it up. And it's just not the way this should be done. There's a better way. It's the delegate pattern. And that's what we're going to refactor to right now. Be sure to take a moment, leave a like, subscribe, keep enjoying this great content. Thanks for your support. So how do we fix this? Well, that requires a beautiful protocol. Here we go. We have a protocol. We're going to call it the roster delegate. And we're going to say it has to conform to any object, meaning anything that conforms to this protocol has to be of an object type. And this protocol is going to have one thing. It's going to say roster to change, and it's going to take a team. Now, when we refactor this, we're going to say to our roster editor, hey, instead of all those classes that we had, and every time we want to update, we're going to just have one thing. We're going to have this delegate, and we're going to say it's weak. So we're not grabbing hold of it tightly. And then we can say, hey, let's create and save our roster. And instead of calling and updating all of those different guys, we can just say to our delegate, hey, our roster changed. Do whatever you need to do. We can think of the delegate or this protocol as kind of like a job contract. And the delegate is the person who we've hired to do that job. So now that we've set this up, our next step is to conform all of our subclasses, and they have to be classes so that we can do a weak reference. We have to conform them to our delegate protocol. And so we do that for the stats panel, and we do that for the battle simulator and the lineup card. And this is just a minor change from the way that they were originally updating themselves. So now that we've done that, we create our editor, and we can assign the delegate to be the battle simulator. And then we save our roster, and then it'll print out that part of the card. And there we go. We have the simulation here, and we can continue on to do our next little bit with the stats panel and the roster. Those are great. Those just print out just like we saw before. Now, you might be saying to yourself, why this doesn't really save us anything? We're saving multiple times and we're assigning the delegate. It's because we can only have one delegate. Only one person can do this job. But we can work around this. Let's say we wanted to do this all in one way. So we can create this object, which is a roster updater. And what it takes is a whole bunch of things that can do this job. So now we can have a whole bunch of things that come through, and we're also going to say that this roster updater, he does the same thing. He is also a roster delegate. So now I can assign him to be the delegate, but when I create him, I'm going to pass in all 3 cards. So now when I run this last little bit, we get it, and we get the same thing. We get the simulation, we get the stats, and we get the lineup cards. And that way, we kind of get the best of both worlds. We only have a single place to update who we want and what we want to have happen. And then he just goes and does a nice little for loop, and I don't have to update everything everywhere. The key signal here to recognize is that with all of these changes, we've had to do nothing to our editor. Our editor has remained exactly the same. All he's done is say, hey, my roster changed. I'm just telling people that they need to do whatever job they need to do to update themselves for the roster. So whether that's single classes at a time or a whole group of classes all together, the editor didn't care. He just said, hey, go do your job. Let's go back to why we've added this keyword here, week. We've added week so that we don't retain a memory pointer to whatever the delegate is. That way, when it's released, I lose access to it. So it's gone, and I don't need to worry about retaining access to it. And we can see in this case, what we're going to do is we're going to create a simulator. We're going to assign it as the delegate, and in this pool, we're going to do it. So this is in a little do thing so that it's in this scope. Now, if this is working right, when I call save here, I shouldn't get anything because there is no delegate because it's been released. So let's call this. Let's look at our printout. It's going to be dope. So here we go. We've printed it off. The simulator is about to go out of scope. It's deallocated. And then we saved again, but we didn't get the second printout. Now, if we remove our week requirement and we run this page again, we don't get so lucky. We've called with no delegate, but actually there still is a delegate. That's because we are telling our roster editor to retain a hard reference to that. And this can have bad consequences. I remember when I was pretty new to the developing game, and I created a hard reference to my delegate in Swift. This is probably 2015, first time kind of using this. Hadn't really thought through this. Pretty new to development too. And what happened is that I had this scroll view with a lot of a table view. It had all these cells in it, and these had references to video players. All of my video player references ended up storing a hard reference to the video player delegate, which meant it was having a hard reference to the video player. And this meant that through a series of bugs that after you scrolled enough, you would stop playing videos altogether. All because I had missed this weird bug. Delegates aren't dead in the world of SwiftUI. They're just one more tool in a greater toolbox. There's a lot of options right now in Swift for passing information around. You got Combine, you got async await, you've got notification center, you've got delegates, you've got closures, and each one has their place. This is my take. I think that closures are great for one-off calls. Hey, I want to do this one time. Let's get it done. So like, let's say you had a scout recruiting board and you wanted to do something when you scout a single guy. Okay, great. Delegates are useful when you want an ongoing relation. Hey, every time I change this board, I need to update whoever's going to be listening. I just want to say, hey, you guys need to do what you need to do. Notification center is another tool we can use. And that's a pretty good one when you want to tell lots of people and you don't want to really know about them. So you're just kind of announcing to the world, hey, I've changed something. Why don't you respond to it? We can see that here if we created a notification that our roster updated and we wanted to announce it just broadly to our system so that anyone, anywhere can listen to that. So we can have the roster broadcaster and he just says, hey, we updated this. And then we could have our different classes respond to that. So they need to actually go in and know about this notification and then listen for it. And we could do the same thing like with our training scheduler, or we could update our other previous classes like the simulator or the lineup or the card to listen for this. And we could just broadcast out generally that this event happened. We updated our roster and here's the team info. And then that will go through and print off the stuff in a different way. In SwiftUI, like we've kind of mentioned before, it's a little bit different. In SwiftUI, this is a more reactive programming way, in where you use things like observable instead of delegates, or you use publishers that send out things and say, hey, I need whoever's downstream of this to react to it. And when you do that, the views automatically react to those changes. They subscribe to the publishers, they subscribe to these async await delegate methods, and then they just automatically update. So you don't need a delegate. It's a slightly different way of looking at it, though. So in general, when to use what, async and combine, let's use streams in SwiftUI. Notification center, it's a one-to-many. You want lots of people to listen to it. Closures, it's a one-shot. Hey, I need this to happen when I do this. And delegates, when you're going from one to one, or you have multiple methods for the same person to implement. Be sure to take a moment, leave a like, subscribe, keep enjoying this great content. Thanks for your support.